Welcome to this tutorial on C# inheritance in Unity 3D, where we'll focus on creating a robust base character class. Inheritance is a fundamental concept in object-oriented programming, allowing you to build new classes upon existing ones, promoting code reuse and better organization. In this video, we will create a foundational character class and then extend it to develop various specific character types for your Unity projects. Let's begin by opening Visual Studio and creating a new C# script named character.cs within our Unity project. This character class will serve as our base, containing all the common properties and methods that every character in our game will share. First, we include using Unity Engine to access Unity-specific functionalities essential for our game objects. Next, we declare our public class character, ensuring it inherits from MonoBehavior so it can be attached to Unity game objects. Inside, we define public variables for character name, health, and mana, which are fundamental attributes for any character. We also introduce virtual methods, attack and take damage. The virtual keyword is crucial as it allows derived classes to customize these behaviors. The attack method will log a basic attack message, indicating the character's action, and take damage will reduce the character's health, then log the damage taken and the remaining health. Now that our base character class is complete, let's create specialized derived classes that inherit from it. We'll create two new C# scripts, warrior.cs and mage.cs, representing distinct character types. For the warrior class, we declare it to inherit from character using the colon syntax. Public class warrior, character. The warrior will have its own unique ability, a special attack method, demonstrating how derived classes can add new functionalities. We also override the base attack method to provide a warrior-specific attack description, showcasing polymorphism. Similarly, for the mage class, we ensure it inherits from character as well. The mage gains a unique cast spell method, reflecting its magical capabilities. And just like the warrior, the mage overrides the attack method to perform a magic-based attack. Notice how both warrior and mage automatically inherit character name, health, and mana from the base character class, without needing to redefine them. Now, let's switch back to the Unity editor to see these inherited classes in action. We'll create a new Unity scene for our demonstration. Next, create two empty game objects, one named warrior object and another mage object. Attach the warrior.cs script to warrior object and the mage.cs script to mage object in the inspector. Observe how character name, health, and mana fields automatically appear in the inspector for both objects, inherited directly from our character base class. Let's set some initial values for character name, health, and mana for both our warrior and mage. To demonstrate calling these methods, we'll create a simple GameManager.cs script. This game manager will hold references to our warrior and mage objects and call their respective methods. Inside the start method, we'll initialize their names and health, then invoke their attack, special attack, cast spell, and take damage methods. Attach this GameManager.cs script to an empty game object in our scene. Then, drag the warrior object and mage object into their corresponding fields in the Game Manager scripts inspector. Now, run the game and observe the Unity console. You'll see the output from each method call, confirming our inheritance setup works as expected. Let's explore some helpful tips and best practices when working with inheritance in C# and Unity. Consider using abstract classes and methods if you have functionalities that must be implemented by derived classes. Abstract methods declare a contract, forcing all non-abstract derived classes to provide their own implementation. Another important concept is the choice between composition and inheritance. Sometimes, using components is more flexible than deep inheritance hierarchies. When overriding methods, remember you can call the base class's implementation using base.method name if you want to extend, rather than completely replace, its behavior. Understanding access modifiers like public, private, and protected is crucial for controlling visibility within inheritance. Protected members are accessible within the class itself and by any derived classes, offering a balance between public and private. In summary, inheritance is a powerful tool for code reuse, organization, and creating flexible game systems in Unity. By creating a base character class, we established a foundation for all our character types. making our code more manageable and scalable. We saw how derived classes like Warrior and Mage can extend and specialize the base class's functionalities, adding unique behaviors while retaining common attributes. The demonstration in Unity showcased how these inherited properties and methods seamlessly integrate into your game development workflow. We also covered essential tips, including abstract classes, the composition versus inheritance debate, and the proper use of base and access modifiers. We encourage you to experiment with these concepts in your own Unity projects to solidify your understanding. Thank you for watching this tutorial on C# inheritance in Unity 3D. If you found this video helpful, please like, subscribe, and leave your comments below. For further learning, explore the official Unity documentation and C# programming tutorials.